Three, two, one. Hi everyone. We're our first track today, and our first speaker, Mat Ryer. Matt is founder of PaceDev, and also he's regular host in GoTime podcast. Today, Matt is gonna talk about one of the coolest Go feature called Defer. So, hi, Matt.
Hello.
Please start. Yeah.
Okay. I'll do so. Hello, everybody. It's an honor to be here at GoWayFest. I mean, obviously, I'm not here, but it's still an honor. And hopefully, one day we will get to do this again in person. Yes. Thank you for that intro. Thank you also to everyone that puts these conferences on. I know there's a lot of hard work goes on behind the scenes, so I very much do appreciate that. Today, I'm going to talk about Defer. Defer is my favorite Go feature, actually. And it's because it has simplicity. It's kind of a simple idea. It's minimalist. You can't do a lot with it, really. But it's extremely powerful. And that kind of, I think, is also what attracts us to Go. It's certainly what attracts me to Go. So this is me. I co-founded Pace, which is a project management tool. I'll show you a little screenshot in a moment. I also did the Go Programming Blueprints book, which is, still available. Help yourselves. I'm terrible at promoting things. I just pretend I'm reading it sometimes. I'm like, oh, sorry, I didn't see you there. Just reading that. I do the Go Time podcast as well, and we do this live. We do the podcast live, a bit like this. So you get to listen into conversations and bits and pieces. So please join us if you haven't heard of the podcast. It's very fun. And also I'm on Twitter, and I like to answer questions about Go on Twitter. So genuinely, if you've got any particular questions, then ask away. We did a Go Time episode on Defer, actually, and I recommend it only because it's directly relevant to my talk, but also we speak to the person that did the actual work on the optimizations of Defer, which I'll talk about as well today. So this is Pace. It's a minimalist project management tool. So, we were like, Jira was just way too complicated, even for us, and we're programmers, and we're used to complicated things. And Slack kept interrupting us too much. So this is why we're building Pace. And a lot of the technical, there's a lot of good technical work in building something like Pace. And when I was looking at this for writing a talk about Defer, I wondered, how long in 6 months, how many defers have we used? So I searched, and it's 418 defers. That's an average of 69 defers per month. And I don't know how you measure performance, but we measure it with the use of defer. That's how much we like this feature. So in this talk, I'm going to have hopefully something for everybody. We'll look at, in the beginning, for beginners, we'll look at what defer is and how we can use it to make our code better. We'll also look at common gotchas, things to look out for when you do use defer. And then we're going to look under the hood and figure out, how does defer actually work under the hood, and what's happened recently in the language that's made defer better. And I will answer the question, should I be using defer? And I mean, I've spoiled it, haven't I? The answer is, yeah, I think you should, but we'll see. So what is defer? Well, basically, they're functions that are called before the surrounding function exits, before it returns. And they're called in the reverse order, which really makes sense. So, for example, here's some Go code. And, we're used to typing code out like this and calling methods and expecting them to be called. This is sort of normal kind of coding, I guess. And if we call the goodbye function first, and then we call the hello function, of course, it's going to print goodbye and then hello. If I put the defer in front of that goodbye, then the goodbye gets called second. And that's because it waits until the main function exits, and then it calls defer. So that's really it. There's not a great deal more to know about that. we can just make sure we've grasped it in another example. Look, here I've got a main function and I'm calling 1, 2, 3, but I'm deferring them all. So what does this print? You'd be forgiven for assuming it printed 1, 2, 3, but remember it's reverse order. So they get called like this. 3 gets called first, then 2, and then 1. So this is in computer talk. This is LIFO, apparently. It's last in, first out. So now we know what defer is. When should we use it? What are some good actual use cases for using it? Well, here's a great one. Whenever you are working with files, you have to remember to close those files. If your program opens a file, it's responsible for closing it. And if it doesn't, you can cause leaks, memory leaks, and open file handles, and all sorts of problems, of course. So it makes sense that we want to close those files. So how do we do it? Well, in a sense, this works. This do something impressive function. And by the way, a little tip for junior devs, all you have to do is write functions that do something impressive, So that's it. If you can do that, you're sorted. In this impressive example, you can see that I'm opening these two files, and then I'm file 1 and file 2. I pass them both into this process text function, and it's going to go and do its work. And then I close the files afterwards. Now that makes perfect sense, doesn't it? However, there's a few problems here, and these extremely long arrows are going to show us where those problems are. So at number 1 here, look, if the code reached here and couldn't open that second file, it's going to return the error, right? That's one thing we like about Go, is this explicit error handling. But what does that mean? That means we've left that first file open. So we've actually leaked a file there. And similarly, in the second case where number 2 is marked, if that process text function fails, we're just going to return the error without closing the files, because the file closing is further down. So this is a perfect case for defer. We could do it like this. We could open code a solution, right? So it basically means we're going to find all the places we can exit, and we're going to call all the things we need to tidy up. In this example, that's actually not too bad. It's a bit repetitive, but not so bad. But imagine if you had 7 or 8 things going on, and you had to sort of remember, and these they're not always the same each time. They build up over the course of the code, so it's kind of not a great pattern. It quickly becomes quite tiresome, but we can use these defers, and that's what we do. So in this case now, we open file 1, and then we defer immediately the close of that file, right? So now, wherever we exit, whether it's an error or if it's the happy return nil at the end, we've closed that file. So this is a way to make sure that we are cleaning up after ourselves. And Michael McLaughlin from Uber points something out about this, and he's got a point here. He says that this encourages ignoring that IO closer, the close method's error that gets returned. So that close method can return an error. Now, in most cases, they don't. But when you're writing a file, for example, then it does in that case, because there might be some stuff still in the buffers internally. And when you close the writer for a file, it will finish writing those final bits. And of course, whenever it's writing, that can cause errors. So personally, if we had a time machine, I'd go back. Actually, I'd go back to when my granddad was still alive, because he still owes me £10. But second thing I'd do is go and have IO closer, have the close method not return an error in the Go language design. In the writing a file case, there's a special method, I think it's sync, that you call, and that will finish any final things. It's a bit like flush as well, those kinds of ideas where there's some internal state and it needs cleaning up. So you have to be aware of that. But in most cases, it actually is fine to just defer the close of an error. Another example in our effort to do something impressive, where we might use defer, is when you're making HTTP requests. So if you do a GET request, or any actual request that contains a body in the response, you're responsible for closing that response body. So again, you could leak files if you don't do this. You could leak file handles and leak memory and things. So you have to remember to do it, and you can do it here. You just say, we're going to close this. We just defer it. So as you check the error first, and then usually you do your defer. And it's nice. It's all in one place, isn't it? The code that gets this response and then also tidies up is together. And that's quite an important philosophical point, I think, as well, is because we care about maintainability. So having everything in one place is a great way to make code easier to maintain. And this is a way to do that. We can use defers also when we're working with locks. It's really about there being a pair of operations that have to happen. So here I've modeled what can only be described as a kitchen, and it's going to take an order. And because it's got some internal state, we have to protect that state. We don't want people to have to form a queue to make requests to our kitchen. We want them to just be able to make any requests they want anytime. And we'll deal with that. That means we have to protect our state internally concurrently. And locks are a way to do that. And so this is a simple example where we lock the lock in the beginning. And if someone else tries to make an order meanwhile, and they hit that, if it's locked, they will block and wait for it to unlock, and then they carry on. Okay, so this is a way to protect, so we don't have data races and other kinds of problems like that. So in this case, it seems fine, but again, there are places where we may have a problem. So at number 1 here, we make the lock, we do all our work, and then at the end, we unlock. But there's 3 places pointed out by these spectacularly long long arrows. I think we should have more long arrows, by the way, just a personal thing. They're pointing to places where we could exit and leave the kitchen locked. So it's a bit like you make an invalid order to a kitchen and they just shut down, which is unreasonable. So we want to do a bit better. And we can use a defer in this case. So now we lock and we defer the unlock. And then it doesn't matter what goes on now. Wherever we exit in this function, we know that we're going to unlock the kitchen at the end of it. Now, somebody in the past pointed out here that this could be a little bit inefficient because you're locking the kitchen for quite a long time. If you could pinpoint just the calls where you're going to change state and have locks around that can be an optimization that you make. But actually, there's something else about doing this in this way, and that is that it makes the code not only more maintainable, but easier to write as well. Jana Dogan on Twitter points out that if your attention is easily pulled elsewhere, doing the thing and then doing the cleanup immediately is very nice kind of cognitive or automation that you get to benefit from. So there's a trade-off with performance. You might choose the more performant one, or maybe you go for readability, and it'll depend on your particular case. My general rule is write maintainable code, and then once you've got users, you measure and find out where you can do improvements. That's generally the approach, and that means by default you have nice readable code. In some places you might have some messy or difficult to follow code, but that's really tuned for performance. But honestly, most of us will never really need to worry about that. So another thing about defers that's worth remembering is that they work with conditions too. So in this case, I have passed in a secret order. This kitchen keeps getting better. Now you can make secret orders to the kitchen. So I make a secret order, and only in this case Only if it's not secret do I want to meddle around with that internal state. And therefore, I only need to lock in that case. And therefore, I only need to unlock in that case. Now, notice that the defer here, I'm just using it normally, but it's inside this if condition. So that's kind of a clue that there's some runtime magic to defer. And we'll figure out what that is soon. So another example is in test code. If you want to tidy things up, sometimes there's a lovely pattern where you can return a function that does all the tidy up. So in this case, here at number 1, we have this cleanup func type, which is just an empty function. So very simple. We've got this create test files function, which is going to return the test files it created, but it's also going to return the cleanup func. And I can declare that internally, just inside this other function. And in there, I can do any work I need to tidy up these test files. So this creates a very nice API such that we can do things like this. Look, we just use it like we call create test files. We grab the test files, we grab cleanup, and then we just immediately defer cleanup. And then even if we have failures in our test, we know the deferred code will run and they'll be tidied up. So that could be deleting files. It could be closing things. It's putting back whatever disruption you caused throughout your program, really. So that's a lovely example of a way to use defer for testing. But you don't have to only use it for testing. You can build real APIs that use this pattern as well. In fact, here's all the code for a HTTP handler timer. So again, we've got this stop function at the top. We use new timer, which is going to, first it catches the start time. Then it creates this stop handler. And it's the stop handler that it's going to return. But notice it has access, because it's a function that's declared, it's an anonymous function essentially that's declared inside this other one. It has access to the variables around it. So we can access that time, the start value, and use time.since to find out how long it took. And all that state, everything just lives in that one little function. And then to use it, we just call stop, we call new timer, that returns us the stop. We can defer the stop, and then we just go about our business. And in this case, it will just print out how long this timer took. That could be integrated into some monitoring system or something, whatever you need. So you get to build APIs that rely on defer as well, and you should, because it's lovely. I mean, it also takes away it's very difficult to abuse this API if you make it. If all you're returning is another function, all they can really do is call that function. So it's kind of nice, sort of nice for building no-brainer APIs. This is tempting, but should be resisted at all costs, I think. This is technically correct, but what's happening here? At first glance, it looks like we're deferring this setup function, doesn't it? But we're not. We call the setup function immediately, and then that's returning a teardown function, and that's the function we're deferring. I've seen code like this, and it's just a little bit too weird, I think. So I prefer this. Essentially, call setup, grab the teardown, store it in a thing called teardown. You know what I mean? Like tell a bit of a story around this code. And then you get to defer teardown. You know what I mean? Like you really are. That's how we think about this. We're going to set something up and we're going to tear it down. We'll defer the teardown. You're almost writing English at this point, So it's kind of very nice to build these sorts of APIs, but avoid being too clever and squashing things. And I think that's a general rule that I always think is important. So it's time for a fact of the day. Ken Thompson came up with the idea of defer, and it was probably influenced by the Plan 9 kernel error handling stack, which is documented today at this insecure address. I'm going to talk a little bit now about common gotchas, because there's a few places where defer gets a little bit strange and you can see some weird behaviors. And in 99% of the cases, it's the same problem recurring. So I'll tell you about that problem so you can watch out for it. Have you seen this optical illusion, though, by the way? You probably have. But for anyone who hasn't, this is real. Those two squares, that A and that B, have the same background color. And it's the software in our brain is malfunctioning essentially and makes us think that that B is a lighter square. Check it. I'm not kidding. I've even checked it. Look, it's 5C. They're both 5C. That's a common gotcha in real life. So now we're going to look at a common gotcha in defer. That's the weakest link I've ever done, I think, probably. Excuse me. By the way, make yourselves at home. You know, if you want some coffee or whatever, just have some. Do what you want. You're in your own house. What does this code print? You'd be forgiven again if you said 1 to 10. But look, well, you may not be forgiven now because I've told you already, haven't I? They run in reverse order. So now you'd be forgiven if you said 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. That's what we would expect to happen. But it's a common gotchas round, isn't it? So obviously 10, 10, 10, 10, 10, 10, 10, 10, 10, 10 instead, which is wrong. So what's happened there? Well, check it out. That's slightly missed. That's meant to be around the item. The item variable there that I've neatly circled is being reused in this loop. And so the defers are all getting queued up, but because that item variable is getting reused, you're left with the last setting, which is 10, the last value. So that's not quite right. Also, good aim. Really good aim. So we can get around this by making a little helper function. So you can see I've just made an anonymous function again, but assigned it to the handle variable. And then I'm deferring that handle and passing the item in as an argument. So this changes it now because there's some state there that it has to catch while it's being scheduled, right? So it's at the time you've written defer, it will catch the correct value now. And you can see we print the numbers as we expect them. So this is really interesting. Now you can write it in this way where you have a little anonymous function and then you call that function, or you can just do away with the variable and do it in line. And really it's just about whatever reads well, I would say. If that deferred function was more than just one or two lines and was quite big, it's nice to have it pulled out in its own place. It's just nice for sort of maintainability. But you don't have to. It is a style choice you get to make. But this is nice. You can just do this little pattern if you're doing something simple, and it's clear what's happening, I think. If you want some more gotchas, check out these ones by Inak Gummus because he's done a 3-parter on various. Some of them are more forms of that. That's the most common one, with the variables being reused and presenting kind of confusing behavior. But there's others as well, so check them out. They're very cool. So how does defer actually work? This is very interesting, I think. I went poking around. Remember, Go is open source, and it's written in Go, which means technically we can read it and contribute to it. Well, I say we can read it. Some places they look like they're writing C code still, and this is one of those cases. This is the defer struct. This is a type that is created every time you defer something. So during the compilation, it creates one of these defer structs. And, there's some, it's not an easy API. It's not an easy thing to understand, actually, if you look at this. And that's because it probably contains a lot of domain knowledge, like FN, PC, SP, these field names. You wouldn't call field names that probably unless they were very obvious in a particular domain. And so if you're writing compilers and things like this, you end up with this sort of other language. I prefer code to be just more verbose and more clear than this, if I'm honest. But there is something quite interesting, and just using my laser focused, yes, I did it this time, circled the right thing. We have here this little field called link, and it's a pointer, look, to this same type. So that's interesting. What that means is defers essentially are a linked list. So the one defer points to the next one, which points to the next one. And they do so through that variable. So, for example, if we have this simple function and we're going to defer calls 1 to 5, the first thing that will happen is at the end of the function, it's going to call 1. So one of those defer types gets created for that. When we then defer 2, another type gets created, and it's the 2 that's linking to the 1. So that reference gets added, and it's literally that defer field type. Same thing happens then when we defer number 3. That one links to 2, and 2, of course, links to 1. So when we then defer 4, we then are pointing to the number 4, and that's pointing to 3. Same for 5. And that's why you end up with this reverse order. And also, these linked lists are extremely efficient. It means these defers don't have to be next to each other in memory. They can be all over the place. But it's still fast because it's just a kind of lookup. So you can still quite quickly traverse this list. So that's what's literally going on under the hood of defer. It's time for another fact of the day. Defer was originally called catch. And check out these alternatives also. Undo, which would be weird. And I quite like on return. I could imagine on return, like it feels like there's an event, there's a return event. So on return, call this. But I think defer wins. I think they picked the right one. So what's this defer performance problem that we've heard about then? And I have heard this. I've heard that people say, we can't use defer in this case or whatever because it doesn't perform well. Well, in most cases, it doesn't matter. This won't be the slowest part of your program. In some cases, it does matter if you've got either code that's running lots and lots of times, or if you are running code at massive scale and having lots and lots and lots of users, then of course these nanoseconds add up. That's just time and maths, I think. So what's going on here? Well, like I said, remember that there's that condition. So it's possible, there's runtime effort that has to happen. It's got to walk that list. It's got to do some things. If there's conditions called, as you're calling defer when you runs down your program, it's got to do some scheduling to do that. You know what I mean? There's effort happening at runtime. And this is how long that effort essentially takes. So in Go 1.3, which is pretty good, it was down to 35 nanoseconds. But bear in mind, a naked function call is just 3 nanoseconds. I can see why people in those low latency situations were concerned by this. In most cases, like I say, that difference will be insignificant, and you'll have other bottlenecks that matter more. But let's go with it. Let's say, right, we want to fix this. How can we improve defer? Well, there is a solution which is called open coding, and we saw an example before. But let's have a look at a different example. Lots of people are making bread, so here's a function that makes some bread. We get the dough. We defer putting the dough back. We get seeds, and we defer putting the seeds back. And then we add them together and you bake it. And that's how you do it. But look, if we open code these, if we didn't use defer, we would be putting this code at every exit point. So the compiler could do that for us, couldn't it? It can look at our input code and think, well, I can see what's happening just by static analysis. And actually it does do that. If it can, it does. But it doesn't help for situations where you can't use static analysis, like in the situation of conditionals. So in this example, I've added this with seeds option, and only if that's true are we going to put the seeds in and get them. So we don't need to put them back if that bool is not set. So now we can't do that at kind of static analysis time because we're not sure whether we need to call seeds put back or not, are we? And so this is one of the most exciting improvements, I think, to defer that we've seen. It happens to be in Go 1.14, so brand new. The compiler is going to do that for you. It's going to do these open-coded defers. So it only works in situations where defer is called 0 or once. So it won't work in loops. For loops and for other situations, it'll fall back to the original implementation. But for cases where this works, the compiler is going to assign a bit for every defer. And then when the code runs in that closure or in the conditional, it can just set the bit. And then when it comes to open coding it, it can just, still going to go and put the code in all the places, but it can check to see if that bit is set or not, because it got set at some point during runtime potentially or not. So this there is a little bit of runtime work, but it's just checking a bit and it's very quick. And this is what it looks like. Essentially, you write, we're going to defer this one function, and then if with seeds, we're going to defer the second function, turns into something like this. We've got some defer bits, and if with seeds is set, we set the bit for this defer. So we set the 0 to 1, and then later, before we return, we're just doing a quick check to see if we should indeed do that or not. But it only works for a specific number of defers, and I wonder if you can identify from this code how many. This code looks like it was written by a cat, doesn't it? That's walked across your keyboard, but it wasn't. There's a lot of brains that's gone into this. I don't want to insult the people, but it's hard to read. But I'm zooming in slowly on the answer. We've got this uint 8 type, which is an unsigned integer 8. And so that means there's 8 bits we can flag on and off. And so there are 8 defers that you're allowed per function to get this optimization. If you have 9 defers, don't worry, everything still works. It just won't necessarily use this optimization. The compiler will do this work for you. But let's see how we did. So 35 nanoseconds in Go 1.3. Remember, naked just calling a function directly is only 3 nanoseconds. Well, with this new optimization in Go 1.4, it's actually down to 4 nanoseconds. If you've got 8 or less defers, 8 or fewer defers, then you're only looking at 4 nanoseconds now. So the question of should I use defer for performance reasons, I think, has been well answered. Here's another fact. A lot of the design discussion for defer happened on Google Wave, which was, it's gone. It's just been, I suppose someone's just deleted it because that discussion is now all sadly lost. So I promised I would answer this question. Should we use defer? This will come as no surprise. I think we should. In fact, I actually think you should go and use defers now because they are very fast. So we can use them to make our code easier to read. So yeah, use defer, especially in Go 1.14, because we have these great new optimizations. And that's it. That's my talk. Sorry, I was supposed to tell him I was done, but thank you very much. Yeah, I really hope everyone uses defer. There's no reason now for performance reasons to not. Oh, I love that. Look at that. Okay. So I'm just on now. I think we're going to do some Q&As. Oh, thanks for the claps. Oh, hey.
Thank you. Thank you very much for your talk. It was great.
Thank you.
It was really interesting. You talked about everything every Go engineer should know about defer. But there are a few questions from our attendees.
Okay. Are there any questions about the long arrows? I get a lot of questions about those really long arrows.
Yeah, absolutely. Yeah, it's the main question, I think.
Yeah. Well, they are. I might start selling them because they're very popular, and I don't see them very often in presentations.
Yeah. So the first question was from the beginning of your talk. So why isn't the defer of close before the error test and possible exit?
Yes. So the rule in Go is if a function returns an error, then all other bets are off. It means you cannot trust the other state that's coming back. So if you follow that rule, it means you have to check the error first. You aren't guaranteed to have a function to defer or anything to defer. And in fact, often you'll get a nil back with an error. If you then try and defer the call to close on a nil, that could be a panic, a runtime panic. So yes, you always check the error first. There are some cases where this wasn't true for a while, but it's all been fixed. So yeah, the general advice is always check the error and then go on to do other things.
Cool. So another question, some of close method return errors. Shall we check errors for close methods in defer?
Yeah, so this was brought up to me as well by Michael McLaughlin. Yes, some close functions return errors. It depends if that's meaningful, I think. If you close a file that you're reading, it just does cleanup. I don't think it's possible for it to return an error. I could be wrong. The other question is, what are you going to do if it does return an error when you've stopped and finished reading something? You probably don't care at that point. So it is a bit of a kind of gray area. I don't think there's a hard and fast rule. Some cases, like when you're writing files, yes, because like I said, in that close operation, it may be finishing the write and, tidying itself up or whatever. And if it's doing a write, that could error. So you have to kind of learn a little bit about what it is that's actually happening and find out. I wish it didn't return an error, that close method, because it'd be nice to have it, like the writer, IO or file writer has that sync method. So it'd be nice if it was all explicit like that, I think, even though we'd all have to type more. Some people don't like typing.
Okay, cool. Thank you. So really the most popular question is
arrows.
Yeah, why aren't the arrows longer?
Why aren't they longer?
Why aren't they longer?
There's just no pleasing some people. You know what I mean? I mean, they have the longest arrows I guarantee anyone has ever seen on the presentation. And then people want them longer. You can't please everyone,
Yeah. Also, there was a little discussion in public chat about the defer usage in loops. In your presentation, there were two approaches how to handle it. The first one is to introduce another function, separate function, and the second is to pass the variable to the. So also there is a popular use case to introduce another variable, like item equal item.
Right.
Is it good way or no?
I don't like that. So what you're talking about specifically is in the loop, if you create a new variable, even if it's got the same name, because it's a different block, you can do that. So they just do like item : equals item. You have a line like that. And I find that to be very strange. So no, I wouldn't do that. I would prefer being boring and being verbose and being a bit more obvious and just pass a variable into a function, because we know what that means when you see it. What does it mean to say item equals item? You could easily, I could imagine myself deleting that if I saw it in a code base, thinking that why is it assigning it to itself? It looks like it's left over from some other behavior. But no, and it does work, but I don't like that. I think we're just better off being explicit. It feels clever when you do stuff like that, but it's explicit.
Cool. Yeah, cool. Thank you very much, Matt. We have some more questions, but we don't have time for Q&A. But you can go to the speakers room and ask Matt any questions you have.
Yeah.
So thank you again.
Thank you. I'm just going to be in the speakers room reading this.
Go.
Yeah. Is that mirrored, by the way, for you? Is that backwards? Is this mirrored?
No.
Oh, it's the normal way. Oh, okay.
Yeah.
I did one once and everything was flipped for some reason. So, okay, I'm glad. Well, I was just joking with that, but you can buy it.
Yeah. Thank you.
Cheers. Oh, and now we have to wave like TV presenter.
Yeah.